Hi everyone, welcome to my channel. Ako nga pala si Jason Reyes and this is your ultimate spot for mastering calculus and integration techniques. For today's video, tutulungan ko kayong maintindihan at mamaster ang mga challenging na integration topics. Whether nahihirapan kayo sa differential integration, trigonometric transformation, inverse trigo-integration, at integration by part. Nandito ako para mas gawing simple, mas klaro ang calculus para sa iyo. So tara, let's go! Logarithmic integration is a method we use when the integrand is a rational expression where the numerator is the derivative of the denominator. In other words, kung makikita mo na ang denominator ay parang derivative lang na nasa ilalim, pwede mo na siyang i-integrate gamit ang log rule. Ang idea dito ay gagamit tayo ng u substitution para ma-convert ito sa form na du over u, and kapag nangyari yun, diretso na tayo sa natural logarithm. Kaya ang formula na ginagamit natin dito ay integral of 1 du over u is equals to ln u plus c. Sa lesson na to, ipapakita natin yung iba't ibang klase na problema na pwede masolve gamit ang log integration. Simula sa pinaka-basic hanggang sa medyo tricky na kailangan ng konting algebraic manipulation. Okay, for our first example, we are solving the integral of 1 over x plus 2 dx. So ang una nating step dito ay substitution. So mag-let u lang tayo. Let u is equals to x plus 2. Then, we differentiate both sides, magiging du. Derivative ng x plus 2 ay 1 dx. Now, we substitute into the integral. X plus 2 becomes u. And dx becomes du. So this turns into 1 over u du. This is now in a form that's very easy to integrate. The integral of 1 over u is just natural log of the absolute value of u. So ln u plus c. Now finally, we substitute back u equals x plus 2. So our final answer is ln absolute value of x plus 2 plus c. So ito na ang final answer natin sa example number 1. So again, if you see a rational function where the denominator is linear, the numerator is just 1, you can let u equal the denominator and it usually turns into the form du over u. That's a signal that you can use the log rule. Okay, ito naman yung second example natin. Meron tayong integral ng 5 over quantity na 2x plus 3. So as usual, check muna natin kung pwedeng mag-substitution. Since yung nasa denominator ay 2x plus 3, let lang natin yun as u. Tapos, i-derive natin both sides. Ang lalabas ay du over 2 dx. Pero sa original problem natin, dx lang ang mayroon. So, solve natin si dx in terms of du. So, magiging dx is equals to 1/2 of du. Ngayon, substitute na natin. Yung 2x plus 3 ang magiging u, tapos yung dx magiging 1/2 du. So, meron na tayong yan. Simplify lang natin yung constants. 5 times 1/2 is 5 over 2. So, equal lang siya sa 5 over 2 integral of 1u du. So, ibalik natin yung u. So final answer. 5/2 ln of the absolute value of 2x plus 3 plus c. So again, when you see something like this where the denominator is linear and the numerator is constant, try letting u equal the denominator, then use substitution to turn it into du over u, and from there, it's an easy log integral. So for our third example, ito, integral ng 2x over quantity x squared plus 1. Now, tignan natin closely. Yung nasa baba ay x squared plus 1, and kung i-derive natin yan, di ba ang lalabas ay 2x. Yan din ang nasa taas. So magiging, mag-let u tayo as u is equals to x squared plus 1, then du is equals to 2x dx. Di sakto, yan din yung nasa numerator ng integral. So pwede natin palitan tong buong expression ng du over u. Alam na natin to. Integral of du over u is equals to ln of the absolute value of u plus c. So magiging ln u plus c. Ibalik natin si u. So the final answer is ln absolute value of x squared plus c. So ayun, perfect example ng log integration kasi exact match yung numerator sa derivative ng denominator. Spot mo agad kung pwede i-let u as sa denominator. Kung yung nasa taas ay du, go na agad sa ln u. Okay, fourth problem natin, integral ng 3x plus 6 over x squared plus 4x. So, as usual, check natin kung pwede tayo mag-substitution. Tignan mo yung denominator, x squared plus 4x. Kapag kinuha natin ang derivative niyan, ano lalabas? So, i-let yun natin as x squared plus 4x du is 2x plus 4 dx. So, ang nasa taas ay 3x plus 6. Hindi much, pero halos kahawig, di ba? Pwede nating i-rewrite yan para lumabas yung 2x plus 4. So, yung 2x plus 4 dx, pwede nating gawin 3/2 2x plus 4 dx. Ayun na, so ibig sabihin, pwede na natin gamitin ng substitution. Basta factor out lang muna tayo. So palitan natin, ang numerator ay 3/2 2x plus 4, then dx. So yan ay magiging 3/2 integral of du over u. Same drill, integral of 1 over u is ln of the absolute value of u. So, ang final answer natin ay ln, ang u natin ay x squared plus 4x. Huwag kakalimutan yung c. So, yan. So, ayun. Kahit hindi agad match yung numerator sa derivative ng denominator, may paraan pa rin. Hanapin mo lang kung pwede mo i-adjust yung numerator. Minsan, kailangan mo lang mag-factor para ma-convert into du over u form. Minsan, hindi lang math skills. Diskarte rin talaga. Okay, for our last problem, tignan natin to. Integral ng 4x over quantity x squared plus 2 raised to the third power. At first glance, parang tempting isipin na log form ulit to kasi may rational function tayo. Polynomial sa numerator, polynomial din sa denominator. Pero wag agad assume, check muna natin kung d over u nga talaga to. So mag-let u tayo as x squared plus 2. d yun is 2x dx. Now, ang numerator natin ay 4x dx. at ang du ay 2x dx. So may konting connection. Actually, pwede natin gawin ito. 4x dx is equals to 2x dx is equals to 2 du. So gawin na nating substitution. Yung denominator na x squared plus 2 raised to 3 ay magiging q cube. And yung numerator with dx becomes 2 du. So ang integral natin ay magiging integral of 2 u cube du. Oops, kita nyo yan? Hindi na siya du over u. Instead, power form na siya. U raised to negative 3. Gamitan natin ang power rule, add 1 sa exponent, so negative 3 plus 1 is negative 2, then divide by new exponent ay magiging negative 1 u squared plus c. Tapos, balik natin yung original na u, so magiging negative 1 x squared plus c. So, ito na ang ating final answer. So, ayan, hindi lahat ng rational looking integrals ay pwedeng isolve gamit ang log rule. Dito, kahit related yung numerator sa derivative ng denominator, hindi siya exact du over u kasi may exponent sa denominator. Kapag may ganito, switch to power rule instead. At lagi niyong tatandaan kung hindi eksakto ang match ng du sa numerator, log rule may not work. I-check lagi bago i-apply. Trigonometric transformation is a technique we use with integrating expression involving powers of sine, cosine, tangent, and other trig functions. Instead of solving them directly, we use identities to simplify the integrals into something more workable. For example, kapag may odd or even powers ng sine or cosine, pwede natin gamitin ng Pythagorean identities para ma-convert ang expression, then apply substitution. Same goes for tangent and secant. Madalas ginagamit natin ang identity ng tan squared x is equals to secant squared x minus 1. Sa video na to, ipapakita natin ang iba't ibang types ng trigonometric integrals gamit ang transformation para mapadali ang integration process. Okay, for our first example, meron tayong integral ng sine squared x times cosine cube x. Since may odd power tayo, which is cosine cube, ito yung iwalay natin para makagamit tayo ng identities. So, magiging sine squared x cos squared x times cos x dx. Now, yung cosine squared x, papalitan natin gamit ang identity na cos squared x is equals to 1 minus sine squared x. Tapos, since may sine at cosine tayo, let's try substitution. So, ang buong integral natin ay magiging integral of u squared 1 minus u squared du. I-distribute lang natin yan, ay magkakaroon tayo ng u squared minus u4 du. Tapos, power rule lang yung gagamitin. So, yung integral nito ay 1/3 u cube minus 1/5 u raised to 5 plus c. I-substitute back natin yung u is equals to sin x. So, ang final answer ay 1/3 sin cube x minus 1/5 sin raised to 5 x plus c. So, ito na ating final answer. So, ayan. Kapag may odd power sa sine or cosine, ang strategy, ihiwalay mo muna yung odd one, convert the rest using identities, then apply substitution. From there, polynomial integration na lang siya. Okay, for this next example, mas simple tayo. Integral ng tangent squared x. Kapag may tangent squared, ito agad ang cue para gamitin natin ang identity na tan squared x is equals to secant squared x minus 1. So magiging secant squared x minus 1 dx. Tapos i-integrate natin yan term by term para mas madali. So secant squared x dx minus 1 dx. Simplifying, yung integral ng secant squared x ay tan x. Integral naman ng 1 dx ay x. So, negative x plus c. So, ito na ating final answer. So, ayan. Kapag may tangent squared, palitan mo agad gamit ang identity. Pag na-breakdown mo na, diretso na sa integration. Walang u substitution na needed. Ito ang perfect example ng pagkabisado mo na ang identity ay magiging mas madali ang pag-solve mo. So for our third example, meron tayong integral of tan cube x secant squared x dx. So kung mapapansin natin, kaya natin gawan ng u substitution. Ilit u natin yung tan x, tapos yung du is secant squared x. So isa-substitute natin siya sa original na integral. So magiging yung tan cube magiging u cube, yung secant squared x dx ay magiging du. So makikita nyo na pwede natin gamitan ng power rule. So yung u cube du ay magiging 1/4 u raised to 4 plus c. Since u substitution tayo, kailangan natin siya ibalik sa original na tan x. So yung final answer natin ay 1/4 tan raised to 4x plus c. So ito na ang ating final answer. So kahit mukhang bagay sa odd power breakdown technique, minsan mas effective kung diretsyo substitution agad. Dito, since secant squared x dx is the derivative of tan x, pwede na tayo mag-use sub agad. Much simpler and correct. Okay, for problem number 4, we are solving sin squared x times cosine squared x dx. Actually, kapag ang form ng problem ay sin squared times cosine squared, may shortcut identity tayo na pwedeng gamitin para mas madali ang solution. So ang sin squared x cos squared x is equal siya sa 1/8 1 minus cos 4x gamit ang power reducing formula. So ang integral natin ay magiging integral of 1/8 1 minus cos 4x dx. Constant lang yung 1/8 kaya pwede natin to ilabas. So magiging 1/8 1 minus cos 4x dx. Now integrate natin bawat term. Yung integral ng 1 ay x at yung integral ng cos 4x ay sin 4x over 4. So, equal 1/8 x minus sin 4x over 4 plus c. Tapos yung panguling step, i-distribute natin yung constant na 1/8 sa dito. So, yung final answer natin ay 1/8 x minus 1/32 sin 4x plus c. So, ito ang ating final answers. So, kapag nakita mo ang sine squared times cosine squared, pwede mo agad gamitin tong identity para mas mabilis. Hindi na kailangan i-expand or mag-apply ng dalawang identities pa. Diretso na sa integration. Okay, for our final example, problem number 5, we are solving the integral of sine raised to the 4th power. Since even power siya, hindi tayo pwede magtabi ng sign para sa substitution. So, gagamitin natin yung power reducing identity na sin squared x is equals to 1 minus cos 2x over 2. So, pag nire-write natin yung integral, magiging 1 minus cos 2x over 2 squared dx. So, kapag in-expand natin yung integral, ay magiging 1 minus 2 cos 2x plus cos squared 2x over 4 dx. So, ilalabas natin ang constant na 1/4. So, magiging 1/4 1 minus 2 cos 2x plus cos squared 2x dx integral. So, applying the identity again for cos squared 2x na cos squared x is equals to 1 plus cos 2x over 2. So, i-apply natin siya sa cos squared 2x. So, ang ating integral ay magiging 1/4 integral of 1 minus 2 cos 2x plus 1 plus cos 4x over 2 dx. Simplifying ay magiging 1/4 3/2 minus 2 cos 2x plus cos 4x over 2 dx. So, integrate na natin term by term. So, 1/4 3/2 of x minus integral of 2 cos 2x dx plus integral of cos 4x over 2. Integrating cos 2x dx ay magiging sin 2x over 2. Ang cos 4x dx naman ay magiging sin 4x over 4. So magiging 1/4 3/2 x minus 2 sin 2x over 2 plus sin 4x over 2 plus c. So, simplify, ang final answer ay i-distribute mo muna natin yung 1/4 na constant dito. So, ang final answer ay 3/8 x minus 1/4 sin 2x plus 1 over 32 sin 4x plus c. So, ito na ang final answer. So, sa ganitong klase ng problem, sign to an even power, ang main technique ay gumamit ng power reducing identity ng paulit-ulit. Una, palitan ang sine squared tapos i-expand, then palitan yung cosine squared kung kailangan. Medyo mahirap pero sunod-sunod lang ang process. Sa topic na to, tatalakayin natin ang mga integrals ng sagot ay inverse trigonometric function. Madalas hindi ito madaling makita agad kaya kailangan natin kabisaduhin ng specific forms para malaman kung kailan lalabas ang arcsine, arctan o arsec. Usually lumalabas ang ganitong integrals kapag may square root or rational expressions. Kaya mahalaga na ma-identify natin kung ano ang formula ang gagamitin base sa itsura ng integrand. Kapag kabisado mo ang patterns na yan, magiging mabilis at madali ang pag-solve. For our first example, we have the integral of 1 over square root of 9 minus x squared. Mapapansin natin na ito ay kahawig ng arcsine form pero may 9 instead of 1 sa numerator. So rewrite muna natin siya in terms of standard form. 1 over square root of 3 squared minus x squared dx. Now, ang formula natin ay integral of 1 over a squared minus x squared dx is equals to arcsine x over a plus c. So in this case, a is equals to 3, kaya ang final answer natin ay sine arcsine x over 3 plus c. So ito na ang ating final answer. Note that we first needed to match the form square root of a squared minus x squared before applying the formula. Always check if you need to factor out or rewrite constants para swak sa identity. For problem number 2, we are solving integral of 1 over 4 plus x squared dx. Medyo kahawig ito ng arctangent formula, so i-check natin. Ang formula ng arctangent ay 1 over a squared plus x squared dx is equals to 1 over a tan arctan x over a plus c. So, i-follow na lang natin yung formula para madaling masolve. So, 1 over ang 4 magiging 2 squared plus x squared dx. So, by the formula, ang answer natin dapat kay 1 over 2 arctan of x over 2 plus c. So, ito ang final answer. For problem number 3, the given is integral of 1 over x times the square root of x squared minus 16 dx. Medyo mas mukhang complicated pero kung kabisado mo ang inverse trig forms, ito ay exact match sa arcsecant formula na 1 over x times the square root of x squared minus a squared 1 over arcsec x over a plus c. Dito, ang x squared minus 16 ay x squared minus 4 squared. So, a is equals to 4. So, ang final answer natin kung gagamitin ang formula is equals to 1 over ang a natin which is 4 secant arcsec x over 4 plus c. So, ito ang final answer para sa number 3. So, tatandaan, kapag ang format ay may x times the square root of x squared minus a squared sa denominator, automatic na arcsecant form ito. Huwag kalimutang gamitin ang absolute value sa loob ng arcsec para maging valid sa domain. For problem number 4, we are solving integral of 1 over 9 plus 4x squared dx. This looks similar to the arctangent form, pero hindi pa siya eksakta, may coefficient ng x squared. So recall, ang formula ng arctan ay integral of 1 over a squared plus x squared is equals to 1 over a arctan u over a plus c. So ang a squared natin dito sa problem ay equals to 9. Yung x squared naman natin ay 4x squared. Kunin natin ang value ng a by square root of 9, so 3. Tapos naman yung x natin ay square root of 4x squared, which is equals to 2x. Meron na tayong mga value sa formula, so plug in lang natin para makuha ang final answer. So ang final answer dito ay 1 over a, which is 3, arctan of u over a, or x over a. Ang x ay 2x over 3 plus c. So ito ang final answer na ng number 4. Okay, for our last example, problem number 5, ang given natin ay integral of 1 over square root of 16 minus x squared dx. Mapapansin natin na ito ay halos kapareho ng arcsine formula na 1 over a squared minus x squared is equals to arcsine x over a plus c. So, i-identify natin muna ang mga values. So, ang a squared natin dito sa problem ay 16. Ang x squared ay x squared. Ang a ay 4. Tapos x. So, i-plug in natin sa formula. So, ang final answer natin dito ay arcsine of x over a, which is x over 4 plus c. So ito ang final answer. So ang key step dito ay i-write muna ang expression sa loob ng square root para maging exact match sa arcsine 4. Kapag nakita mo na ito ay a squared minus x squared, diretso ka na sa sagot gamit ang formula. Dito, a is equals to 4, kaya naging x over 4 sa loob ng arcsine. Integration by parts is a technique used when the integrand is a product of two different kinds of function. Usually one algebraic and one transcendental, like a logarithmic, exponential, or trigonometric function. Ginagamit natin ito kapag substitution alone isn't enough. Ang base formula na ginagamit natin ay galing mismo sa product rule sa differentiation at ito ang itsura niya. Integral of u dv is equals to uv minus integral of v du. Ang challenge dito ay piliin kung sino si u at sino si dv. Para dyan, ginagamit natin ang mnemonic na LIATE para malaman kung anong function ang unahin. Ibig sabihin ng LIATE ay logarithmic, inverse trig, algebraic, trigonometric, and exponential. At sa pagkasunod-sunod na yan, yun ang order ng priority natin sa pagpili ng u. For our first example, we have integral of x times e raised to x dx. Since this is a product of an algebraic function and an exponential function, gagamit tayo ng integration by parts. So una, pipili tayo kung ano ang u at dv. So yung u natin dito by LIAT ay x. Tapos yung dv naman ay e raised to x dx. So, ang du natin ay 1 dx. Tapos, ang v natin ay e raised to x. Tapos, apply yung formula natin na u dv is equals to uv minus integral of v du. I-plug in natin ang mga values, magiging x raised times e raised to x minus integral of e raised to x dx. Simplifying, magiging x times e raised to x minus ang integral ng e raised to x ay e raised to x din. Tapos plus c. So ito na ang final answer. So tandaan, identify muna ang u at dv based on LIATE. Then apply the formula step by step. Dito madali lang kasi ang v at du ay diretso. For problem number 2, we are integrating integral of ln x dx. Kahit isa lang siyang function, di siya kaya ng direct substitution, kaya gagamit tayo ng integration by parts. Isipin natin na may kasama siyang 1, so we can rewrite it as integral of ln x times 1 dx. Tapos pipili tayo kung ano yung u at dv. So base sa LIATE, yung u natin ay ln x, ang dv natin ay 1 dx. So du is equals to 1 over x, tapos yung v ay x. Tapos yung kasunod ay apply the formula. So alam natin yung formula. Integral of u dv is equals to u v minus integral of v du. So i-plug in na natin yung values. Magiging x ln x minus integral of x times 1 over x dx. Simplifying, x ln x minus, makakancel yung x, so magiging 1. Yung integral ng 1 dx ay x, so plus c. So ito na ang final answer. Kapag may logarithmic function, kahit mag-isa lang siya, integration by parts pa rin ang go-to method. Just rewrite it as ln x times 1 para magamit ang formula. For problem number 3, we will solve integral of x cos x dx. This is a product of an algebraic and a trigonometric function. So integration by parts ulit ang gagamitin natin. So magle-let u tayo. Let u is equals to x. dv is equals to cos x dx. Yung du natin ay derivative ng x, which is 1 dx. Yung v natin ay integral ng cos x dx, which is sin x. We choose u as x dahil mas mataas siya sa LIATE kaysa sa cosine, which is trigonometric. So apply the formula. Integral of u dv is equals to uv minus integral of v du. So plug in the values, magkakaroon tayo ng x sin x minus sin x dx. Integral of the sin x dx. So simplifying, the final answer ay x sin x minus integral ng sin x dx is equals to negative cos x. So magiging positive cos x plus c. So ito na ang final answer. Kapag may algebraic at trigonometric function, madalas isang apply lang ng formula ay sapat. Piliin lang ang tamang u, then diretso na. For problem number 4, we are solving integral of x squared times ex e raised to x dx. Since this is a product of an algebraic and an exponential function, integration by parts ulit. Pero this time, kailangan natin gawin to 2 times dahil sa x squared. So magle-let u lang tayo. Let u is equals to x squared du natin ay 2x. dv naman natin ay e raised to x dx. Tapos yung vi, integral niyan, which is e raised to x din. So applying the formula, magkakaroon tayo ng x squared e raised to x minus integral of 2x e raised to x dx. Now solve for 2x e raised to x dx using integration by parts again. So magle-let u ulit tayo. Let u is equals to 2x. Tapos du is equals to 2 dx. Tapos dv is equals to e raised to x dx. Tapos yung v, integral ang e raised to x dx, which is e raised to x. Apply the formula ulit. Magkakaroon tayo ng ito is equals to 2x e raised to x minus integral of 2 e raised to x dx equal to 2x e raised to x minus 2 e raised to x dx. So ito ang value ng ito. So yung final answer ay x squared e raised to x minus 2x e raised to x minus 2ex plus c. I plus pala to. Kapag mataas ang exponent ng x, expect na kailangan mo mag-integration by parts more than once. Bawas-bawas lang ang degree ng x hanggang maubos. Then simplify. So ito ang final answer. For final example, we have integral of arctan x dx. Since this is an inverse trigonometric function, hindi siya pwede sa direct methods. Gagamitin natin ang integration by parts. Isipin na lang natin na may kasama siyang constant na 1 para magamit natin ang integration by parts. So, magle-let u tayo as arctan x. Tapos yung du natin ay derivative ng arctan x, which is 1 over 1 plus x squared dx. Tapos yung dv natin ay ito 1 dx. Tapos yung v natin ay x. We chose u as arctan x dahil inverse trig siya, nasa taas ng LIATE. So applying the formula, magkakaroon tayo ng x arctan x minus integral of x times 1 over x squared plus 1 dx. So solve the remaining integral. Yung answer dito sa integral of x times 1 over x squared plus 1 dx ay ln. Magle-ln tayo. So ito ay magiging x arctan x minus 1/2 ln 1 plus x squared. So finalizing, yung final answer natin ay x arctan x minus 1/2 ln 1 plus x squared plus c. So ito na ang final answer natin. Inverse trig function like arctan x usually require integration by parts. Always remember, rewrite it with a 1. Apply the formula, then solve the leftover integral carefully using substitution. And that wraps up our video tutorial for today. Natapos natin ang 4 na major techniques sa integral calculus. Simula sa logarithmic integration, trigonometric transformation, inverse, trig formula, at integration by parts. Bawat isa may kanya-kanyang paraan ng pag-solve, pero ang pinaka-importante ay matutunan kung kailan at paano sila gamitin. Lagi niyong tatandaan na sa bawat integral problem, mahalaga ang unang akbang. Kilalanin muna ang form ng integrand para alam mo agad kung anong teknik ang babagay. Minsan direct formula lang, minsan kailangan ng substitution o kaya by parts pa. Sana ay nakatulong ang video na to. Hindi lang para masolve ang mga problems, kundi para mas maintindihan ang proseso sa likod ng bawat step. Again, this has been Jason Reyes and thank you for watching. See you sa susunod pang topic sa calculus. Kaya natin to.